Hi everyone, today we are going to be talking about the Angle Angle Similarity Theorem. So first we need to review what does it mean to be similar. When we are talking about two similar figures, we're talking about figures that have the same shape but are different sizes. Side lengths change, but angle measures remain the same, and this is really important for us to recognize. When we use the Angle Angle Similarity Theorem, we are specifically working with triangles. So if two triangles have a pair of corresponding or matching angles that are the same, then the triangles are similar to one another. So in order to show that two triangles are similar, you'll see this symbol, we use it for similar. We need to first show that two sets of angles are congruent. Once we show that, then we are good to go and say that the two triangles are similar by the Angle-Angle Similarity Theorem. So let's practice this. This first example, they tell us that triangle ABC is similar to triangle XYZ. We call this a similarity statement. So it's any time we are declaring which specific parts are similar to one another. So we are given that the measure of angle A is 61 degrees, measure of angle B is 102, and the measure of angle C is 17. Well, combining these two pieces of information, we can solve for the three missing angles in triangle XYZ. Because we know these two triangles are similar, we know that corresponding angles are congruent. How do we know which angles are corresponding? Because the order that our similarity statement is in tells us this. So angle A comes first here, angle X comes first here. These two angles are corresponding. So if angle A is 61 degrees, angle X is 61 degrees. Likewise, angle B is second, angle Y is second. So if angle B is 102, then angle Y is 102 degrees. And lastly, we have angle C in the third position and angle Z in the third position. So if angle C is 17 degrees, then angle Z is also 17 degrees. And that's how we use the similarity statement to make conclusions on a triangle that we have pretty much no information about. So looking at example 2, we have another very similar setup. We are given our similarity statement, and using this, we can fill in all of the angle measures that we do not have. So we are told that the measure of angle P is 9, the measure of angle R is 150, and the measure of angle L is 21. Now, once we know that, we need to establish which angles are corresponding. So, angle P is going to be corresponding with the angle that matches its position in the similarity statement. Since P comes first, it's going to be congruent to the first angle in my second triangle, which is angle N. So if the measure of angle P is 9 degrees, the measure of angle N, wrong color, sorry, measure of angle N will also be 9 degrees. Same thing with angle R and angle S. Both of these are in the second position, so if angle R is 150, then angle S is also 150. And to bring it home, we have angle L in third with angle T. These two must also be congruent, so they are both 21 degrees. Now, we can combine this knowledge with a problem that looks like this, where we are given specific pieces of information on each triangle. So we are told that angle E corresponds to angle M. We are told that the measure of angle QKE, so this angle here, is congruent to angle BHM. And then lastly, the measure of angle E is congruent to the measure of angle M. So I know right off the bat that if angle K and angle H are congruent, if H is 60, then K must also be 60 degrees. And second, if angle E is congruent to angle M, then I know angle M must also be 72 degrees. And right here, I have two sets of corresponding angles that are congruent, so the Angle Angle Similarity Theorem applies. Meaning, I know that these two triangles are similar. So, once we know that, we can fill in the rest of this information pretty easily. So, the measure of BHM, we already did, is 72 degrees. The measure of angle K, we already did, is 60 degrees. The measure of angle B, this is where we have to use the Triangle Sum Theorem. I know that all three angles in a triangle must add up to 180 degrees. So subtracting those two angles I know from 180, I get 48. And then measure of angle KQE, we know that those are corresponding. So if B is 48, then Q is 48 degrees. Next, we have kind of a funky setup here, but should be pretty straightforward because we are told that triangle DEV, so this triangle here, is similar to triangle FWB, this triangle here. So we want to find the measures of all of these angles. So angle DEV, I'm going to mark out right here. And we know that this angle is going to be congruent to this angle because of these two similar triangles. E is my middle letter, W is my middle letter. So I know that if angle W is 81, then angle E must be 81 degrees as well. Angle WBF is right here, and I can find that one because I know that these two angles right here are supplementary, they form a line. So all I have to do is 180 minus 151, and I get 29 for angle WBF. Now the measure of angle EVD is right here, and I know that that is going to be congruent to WBF because they are once again corresponding. So if WBF is 29, then EVD is 29 degrees. BFW is over here, and I know this is corresponding to my 70-degree angle. Since they are corresponding and my two triangles are similar, I know that the angles are congruent. Then lastly, angle BRV, which is this angle in here. Here's where I have to use Triangle Sum Theorem once again. So I know that these two angles are both 29 degrees. So all I do is 180 minus 29 minus another 29. And we are going to get 122 for angle BRV. Now we can apply some algebra using this Angle Angle Similarity Theorem. I am trying to find the value of x, and I know that angle D is corresponding with angle G. So if I can find what the measure of angle G is, then I can set these two things equal to each other because they are corresponding and my triangles are similar. So first, I'm going to use the Triangle Sum Theorem and say that 23 plus 127 plus g must equal 180. I subtract 23 and 127, and I get g to equal 30 degrees. Once I know that 30 must be equal to 5x plus 10. And I go through and I solve for x. Once I'm there, we get x equals 4. Very similar problem here. I see that y is listed first, so I know it matches with angle C. And I'm going to do something a little bit different just to show us a different method for solving these. I'm going to say that angle C equals 6 plus 2x as well. Once I establish that, now I know all three angles in this triangle, so I can set up this equation using what I know about the Triangle Sum Theorem. And then I go through and I collect my like terms. So I have 3x, and then 90 is like with 30, is like with 6, and so I get 126 there equals 180. I subtract 126 from both sides, and so I get 3x equals 54. Last step, I have to divide both sides by 3, and we get x equals 18. Now, when we are dealing with side lengths, this is the last thing we have to talk about, is that corresponding sides must be proportional, which means they must reduce to the same fraction. So, side length 4 and side length 8 is going to tell me my conversion. This is my ratio, 4 to 8. So now I'm told that Wn equals 7, find Tx. So I'm going to call this side length x. Well, I know 4 over 9 has to be equal to x over 7, because both x and 4 are on the same triangle, so I'm going to keep them both on top. And 8 and 7 are on the same triangle, so I'm going to keep them both on the bottom. Now, every single time we solve a proportion, we are going to cross multiply. So 4 times 7 is 28. 8 times x is 8x. I divide out my 8, and so we get x equals 3.5 centimeters. I know that looks like a 6, so let me try to do that better. 3.5 centimeters. If angle NSW equals 55, then XHT, well, once again, these are corresponding angles. The triangles are similar, so we know that the angles are congruent. Now, just like side lengths are proportional, perimeters are proportional as well, and they must match the ratio I just established. So I'm still going to use 4 over 8 because that's my key here. That must equal 10 over x, because 10 matches my small triangle. So if I'm putting my small triangle on top in the first fraction, I need to put it on top in the second fraction. Again, I cross multiply here, and so we get 4x equals 80. Last thing I do is divide out my 4, and I find that the perimeter here is equal to 20 centimeters. And then part D is just a repeat of part B, so we don't even have to worry about it. There you go. That's how we use the Angle Angle Similarity Theorem to not only figure out angle measures, but figure out side lengths and perimeters. As always, let me know if you have any questions. Thank you for watching, and I hope you have a wonderful rest of your day.